Hey, good afternoon. So, really good turnout today. Very excited to have you all here. Want to thank you very much for your time. The session that we're about to kick off is looking at modern data architectures and the kinds of things that our customers are doing with them. So there was, not that many years ago, the way that we had to approach doing analytics projects was really based off of we had to buy a bunch of big architecture and traditional software and build on that. So what we've done is we've looked at a few dozen customers and some of our really key accounts and what they're doing with our services to really be able to launch services, products, features to markets that they never were able to before. So we packed that up into some of the best practices and we'll share with you how they're doing that. So there's going to be two parts. Before we get into the architecture itself, we'll look at the thinking and the process of how it is that some of the best customers use iterative design to be able to launch big data projects and projects that are analytics based. And then the second is then we'll dive into these architectures of how they're doing it. So everybody's used Netflix before, everybody's familiar with Netflix. Now, if we look at content streaming and we look at broadcast, this is not new. Broadcast has been around for a long time. But Netflix does something really, really well. They make the experience enjoyable and they make the recommendations great. So when you watch Netflix, you are watching and you'll see a show and then you just watch the next show and you watch the next show and you should go to bed, but we're all addicts. And then Netflix just knows how to tap onto that. Now, if you look at what you're seeing on the screen here, it isn't just one application. There's a whole set of microservices that are running. You have the stars, and that's what the ratings are, and you have some description, the pictures. But what's interesting is the recommendation bars. Now, the recommendation bars, you have multiple layers of recommendations that are given to you as a viewer. Now, let's say you're watching House of Cards, Season 2, Episode 2, and you finish it. What's a great recommendation? More House of Cards, right? You finish it and you just continue to watch and you continue to watch. But let's say after 8 minutes you get bored and you exit out. What's a terrible recommendation? Is more House of Cards. So what Netflix is doing is there's something called playback analytics, where at all moments they're looking at what you're watching and they're looking at, are you enjoying the experience or not? Are they giving you good recommendations? So that they can then have the microservices compete to give you a different set of recommendations on that day based on your personality and based on your mood. That's fantastic, right? So they really they've taken that personalization and the analytics and they've created a very personal experience. So the way that they do it is they don't start with, we're going to capture all the data in the world and then something magic will happen. They look at it in the way that a lot of our customers do, which is, you've seen charts like this before, which over the course of time, today we have a lot of data, and in 5 years we'll have an incredible amount of data, and in 20 years we'll have an unimaginable amount of data. But really, underneath you've got this blue line, which is, this is the data that if we analyze it, it has some value. So we have to be kind of strategic, and our customers tend to be very strategic in looking at what data you can cherry pick to build your solutions on. So rather than trying to incur all the cost of capturing all the data in the world, can we just narrow down to the data that will matter? So let's look at how that's done. Trying to start with, let's capture all the data, and then question mark, profit. To me, it's kind of like trying to buy all the lottery tickets to win the lottery. Like, you can do it, it's just a really expensive way to do it. So what's a better way to start? I come from an analytics background, and I've done a lot of behavioral analytics over the years. Started doing almost 20 years ago, loyalty programs, and have moved forward since then. If I asked you today, tell me 3 things about you that tell me who you are as a person, not what you look like, but who you are as a person. There's 3 data points that tend to be very consistent at describing who you are. Now, when I'll do this in a smaller group and I'll ask, hey, what do you think those are? People will start with, race and age and income, but then people will start to move towards behavioral factors like purchases. Purchases are the #1 biggest indicator of who you are as a person, not what you search on the web. And what it tells, like, let's say we look at a shopping basket analysis that's complete enough. I know how many children you have. I know, do they exercise? Do you exercise? Do you have a healthy household? Do you have health problems? Do you get paid every 14 days or 28 days? There's a huge amount of information that's about a person's daily life. Now, the second is if you're looking to connect with a person, you want to know when and where. So it's crazy. Any mobile app that you download now or any website you go to is asking you, like, can I get your location or can I get your GPS? But why? Why is this so relevant? the location, let's say that you've got a household and you've got small people in your house and it's chaos in the morning because you have to make sure they're fed and they're clothed before they go out the door. This is the wrong time to reach out to that person to reach them, say, with a targeted marketing offer. That person may be the right time to reach them is during their commute or during their first 2 hours at work or whenever that is. So understanding a person's action at a particular time of day at a place is the second biggest indicator. And the third is who that person connects with and on what topics. So it's not just about Facebook friends or LinkedIn connections. It's the topics that are shared, because if you can connect with one person who's influential on, say, travel plans or on fashion or on food, that person's ideas will ripple out to a larger community. Now, if you can capture these 3 data points about individuals, you can personalize that reach to them in a very, very powerful way. But I want you to think about this. What would it cost you to capture the universe of information of all 3 of these? There's no way, no matter how big your company is, there's no way you could afford to capture all of it. So how do we look at this more strategically? We start with, first of all, not the data, which is the trap that we've been in the past, or it's the way that we've approached it in the past, is let's start with the data and then build business cases. Well, the better approach is we start with which metrics are you looking to affect within your organization? Let's pick something like brand advocacy. Now, a common measure for brand advocacy is something called Net Promoter Score, or NPS. And it may be different for different industries, but you say, okay, I want to run a project and I want to run an initiative where we create a better brand advocacy within our customers. We know that we want to affect NPS. Now let's go back and let's figure out the smallest amount of data that we need to test our hypothesis on if we can affect NPS. So as we run a campaign or we run an activity, what's the smallest amount of data? And now let's use the minimal amount of infrastructure to be able to move the data, test it, and then move that into the outcomes. So you can start to look at those metrics and see if you're affecting it. Now, if you think of this from a hypothesis standpoint, this means that you can run several different ideas or several different experiments without having that huge upfront cost of trying to load all the data into huge platforms to even get started on day one. So here's what you can use. Let's say you build a template, and I'm sure you've heard in earlier sessions, and you'll hear through the rest of the summit, about this idea of infrastructure as code. So you come up with this template and you say, this is the amount of storage that I need and the amount of data processing and the amount of analytics and then the delivery system. I'm going to templatize that. And then based on that, I'm going to use something called a cloud formation. So I'm just going to create that template as code. And now I'm going to deploy this exact same template for every single experiment I run. Now this template may cost you $150 per experiment, or it may cost you $200 per experiment. Now, what we see typically is that no matter how smart you are and your people are, 8 or 9 of your 10 ideas are not going to go anywhere. Like, you're going to have hypotheses, and some are great, but some are going to fail. So once you find the ones that are good, you can take those and you can scale those and throw out the others. But because they've been built up as sandboxes that are templatized, those don't leave artifacts. It doesn't leave trash around your system. Your experiments don't leave this collateral damage. So the idea that you can templatize, test your experiment, and then once that experiment is working, you can scale it, roll that to production, and then throw out the failed experiments. So let's look now at what that looks like. So we talked about the template. So how does the template look like underneath? Now, we've got a lot of services, and you would have heard Werner earlier say that we've got heaps now. We've got over 80 services. So what we'll do for this session is I'm going to dig in and just look at a few categories here. We'll look at storage, we'll look at security, at analytics, and AI, and how these will string together for sort of a common pattern. Now, for those who are not as familiar with some of the underpinnings of AWS services, there's about 16 services that I'll talk today and give you a little bit of background and how they fit together. So there's two parts of this, and if you're familiar with data architectures, you tend to have a scale side and a speed side. So let's start first with business outcomes at scale. Now, we talked about that starting from the outcomes that you want and working backwards. The first most common outcome that our customers are after is a modernization or consolidation projects. And these tend to take the form of, hey, I know that I've got something that's sitting in my CRM system, but it's really hard for my users to get to it. Or I know that I have something that's locked up in my transactions, but I'm having a hard time getting visibility because these systems are so tightly coupled. So I call these the fear of missing out, or the FOMO applications. This is, I know it's in there, but we're missing opportunities because we can't see that information. So a customer of ours, Aon Benfield, a British-based company, I took this off their Twitter feed. So I was looking at, they've got some fairly interesting projects that they run, but they price risk, and they price risk for their customers. 3 days before Brexit, they put this up and said, if you want, as one of our customers, to come to us and Brexit goes this way or goes that way, we can score your portfolio to say, what's your risk, what's your exposure? And they're the only ones in the market who are offering that as a service. That was pretty cool and very useful for their customers. But they were able to do it because they built, instead of having these old systems on the back, they had huge scale out for HPC, or high performance computing, so that they could run massive scenarios and be able to then sell it back out to their customers as a service. So that's a very common sort of pattern that we'll see. Now, I want you to take a moment and just think about, as you're running projects, start to look at these categories, these bullets, and look, are these things that you're trying to do or trying to do better? So very common projects we'll see, 360 view of customer, 360 view of the business, or what we call insights projects. Digitization, which is, let's get off of either old systems, sometimes even paper-based systems, and move those to a more modern platform. And the third are monetization projects. If you're working in industries that are changing your business models and you're looking at, well, how do we take data, aggregate it, anonymize it, and resell that, or sell it to partners, it would also fall under this pattern. So let's dig into that. This may look familiar to some of you, maybe new to others. This is what we would call a Lambda architecture. Different from Lambda serverless compute, this is a Lambda architecture, and it's a common pattern that's seen for data architectures. And I'll kind of walk you through. On the far right side, you have the personas, and this is where we'll start with those business cases and the metrics that you're trying to affect. All the way on the left side, these are the sources of data that will feed that and feed those questions. There'll be a process where the data source will come in, that's called the ingest, and then it will either be processed for analytics, which is the top layer or the batch layer, or for event handling, which is the speed layer. And then finally, as the information is processed, it will be served out through the serving layer back out to the user. So these are the main boxes, and let's start to fill these in. The data sources for a modernization project tend to fall, there's a lot, and maybe it's slightly different for you, but it tends to be your ERP systems, your transactional systems, and often information that's coming off of your web or mobile applications. Now, that will then move in, and we, of course, since we're an API-based, our services are API-based, you'll have your internet protocols that are used. But I do want to call out that if you have a business that has data transport requirements, so things that can't go across public internet or across VPN, there are also other services like Direct Connect, where you can have a fiber connection between your data centers and ours, so that you can move that data across no matter what your requirements are. I'll talk about a couple key concepts that are used as we build these platforms. The first is around decoupling. Now, decoupling is really a core concept of, instead of having a really big machine, that if we want to go bigger and do more processing, we have to get a bigger machine. It's the idea that if we split the storage and the compute, and we have maybe 3 years of historical data we want to pull in, we can just scale up the storage. Or if we now want to expand out across multiple countries, we can just grow the compute. So by splitting these, we're able to scale more effectively. So underneath this and underpinning this is a service called Amazon Simple Storage Service, or Amazon S3. Now, S3, we have a couple measures. We look at availability, which is 99.95% availability, and something else called durability, which is basically the you never lose data, and that's the 11.9. So 99.99999% means you store 10,000 objects for 10,000 years and you don't lose one. So S3 is an underpinning, and this is our very cheap scalable storage that underpins our services. So this is a really core component. The second that we use is our fully managed Hadoop service called Amazon Elastic MapReduce, or what we'll call EMR. Now, if anybody here has ever tried to stand up a Hadoop cluster and manage a Hadoop cluster, you probably have made a sad face at some point because it's really painful. You have to buy a lot of machines, maintain that, and try to build it. And the trap that people will fall into is, because it's such a pain to do, they tend to build one Hadoop cluster and try to make it do everything. And so there's some different sort of patterns that we see where people use Hadoop more effectively. Now, we do have some features that have come out. If you have used EMR in the past, we now have auto scaling for it. And we also have something which is called the EMR file system, or EMRFS, which is your native read off of S3. It allows you to have a transient Hadoop cluster, which means that because you've split your storage and your compute, you can start Hadoop, you can run it, and you can throw away the compute and not pay for it when you're not using it. Now, if you're not familiar with some of the different ways that you can spin up and use Hadoop, Hadoop it's not sort of the cure for everything. It's really good in a few environments, in a few situations. One configuration is for ETL, and so we'll sort of start on the left and we'll work across. For ETL, often we see customers, particularly if they're coming off of traditional systems, they're using Hive or they're using something that's a SQL based. And this is going to be for batch processing of large amounts of data, tends to be overnight. The language that we hear used is, I have to finish my processing by 5 a.m. for the other downstream processes to work. Now, we have something called a spot market, which is where you get to bid on our unused capacity in the servers. This also means that the customers who are running large-scale batch can say, I'm going to bid on the spot market until 1 in the morning, and then if I don't make it, then I just pay my on-demand prices. So by being able to run really wide for Hadoop and be able to bid on that, then they're able to get some cost savings, typically on several times a week. The second configuration is for processing analytic modeling. So if you have any R programmers or SAS or SPSS, people who have been doing that traditional data mining and data analytics, they treat Hadoop as a grid processing unit. So they can run really, really wide, and they tend to run this during daytime hours. So when the analysts are in, they'll run this, I call this the 9 to 6 cluster. So, and again, because they're persisting the data off into S3, they can use it during the day and then just shut down the compute at night. The third is for processing stream data, or the un and semi-structured data. Now, as this data comes through, these tend to be 24/7 clusters. So these are smaller, whereas the batch for ETL runs really wide and it runs for a couple hours. These tend to be very small clusters, 4 nodes or 8 nodes, that are persistent, and they're always processing clickstream data, or they're processing data off IoT devices. And these will be set up, typically people will optimize using reserved instances, or RIs. Now, a third core component is Amazon Redshift. So for structured data processing and what you would be familiar within the data warehousing space, Redshift is our fully managed data warehousing service. Now, it was designed, of course, to be from day one. It was a cloud native, so it scales from gigabytes up to petabytes. And there are some other features behind this, but what I looked at this in the overall structure is, it's your ability for your end users to issue dashboard queries, BI queries down against your operational data. So how does this start to come together? We start with the data sources. We have an ingest. That ingest moves it into S3. In S3, we tend to have a landing zone called like a raw data storage. There's then an ETL process, and the ETL process, again, running through, typically at nighttime in a big batch layer, it runs through EMR, and it dumps out into a stage data area. Some of our customers will call that a data lake. And what I've done, just for the purpose of not trying to kill you guys with tons of icons, I've simplified some of the steps in between, but generally this is the flow. So there's another set of services, and if you're at the previous presentation, they talked a lot around IAM, or Identity Access Management, and KMS, Key Management Service. So you look at the green icons at the top. These are the next set of services that, as you productionize your workloads, are really important to be able to secure those. So identity control, so role-based control. If you have key management policy, that you'll be able to bring your own keys to the party. And for monitoring and for governance, you also have CloudWatch and CloudTrail, the ability to look at every call that's been issued and look and make sure that your performance levels are staying consistent. So these are the 4 services at the top to build in. Now, as that data comes out of the data lake, or out of that stage data area, and it flows down into the applications that your users will consume, typically it will go into Redshift for data warehousing, again for dashboards, typically in BI queries. Or if you have, say, an existing, we'll call it like a legacy application, something that's running on Oracle or running on Teradata, you may host that inside of the RDS, the Relational Database Service. And that then would allow your, say, business users to use their existing application and take advantage of the data that's been processed within this platform. From the serving layer, you then will have, say, for the data analysts, they may use a visualization tool. And we do have a tool called QuickSight, but you may have a lot of other tools already in your organization. You may have Tableau or Click or any number of MicroStrategy or others. And through Marketplace, you can bring those across and use your licenses for that. If you monetize your data and you want to take this and export it out to, say, third parties, whether those are partners or external customers, API Gateway is what is put in place in between the outside world and your inside world to be able to protect those resources from not just bad actors, but even being able to throttle so that people don't overload your underlying systems. Now, outcome 2, the first was around modernization projects, and the second will be around new revenue. And typically we think of this is the next category of projects around advanced analytics. How data comes in for doing predictions, how data comes in for understanding the things that you know are out there, but you don't know necessarily what they are. So these are what we'll call the known unknowns. And the known unknowns are really that digging into understanding, can the system give you insights that you couldn't get on your own? Another customer of ours is called Robinhood. And Robinhood had a very simple idea. They noticed a gap in the market, which was all of us as personal investors, if we go out, we trade equities or we trade stocks, we have to pay a commission, right? We pay $7 or $10 or something. But institutional investors pay a lot less. They pay nothing. So that's a big gap. So Robinhood said, what if we set ourselves up as an institutional investor and we passed all of that savings back down to the customers, and then what we sell them is we sell them analytics on their portfolio to say, hey, you're investing really well based on your personality or on your risk appetite. And so they were able to then, with two guys, with two DevOps team, they built out the data infrastructure to roll, and I think they did over $1 billion in asset trades, and they handed $22 million back to their customers within the first few months of operation. So within a couple of guys, they rolled out a really effective platform. So these are the kinds of projects that we see in this second outcome, which is personalization projects. Most of you, if you have any sort of consumer-facing part of the business, personalization very likely is going to be something high on the agenda. Demand forecasting, this is again an old discipline that we really see more of that's been moved to the cloud. And risk management, so pricing risk within any of the financial services, that would be a big component. So we start with the same architecture that we had before, so the modernization, which is really that batch layer. But we've added on now from the profiles, there's a slightly different user community. So before we had business analysts and data analysts and externals, now we're talking about data scientists and data analysts and engagement platforms. So they have slightly different consumption needs and requirements. Now the data will flow in and it will still arrive into S3 and get processed. But you also are now looking at real-time data. So as data comes off of Clickstream or it's coming off of some sort of event or processing engine, there'll be a need or a requirement to use some sort of event capture. We have a real-time event streaming service called Kinesis, and it's able, think of this as the on-ramp for events. So as anything's happening, it flows into the system through Kinesis. There's then a second component of this, which is the ability to do analytics directly off of, say, log data. So as data is being generated off your web servers, it's flowing in through the on-ramp, then you're able to process that directly without having to structure and modify that data first. So where this fits in, you see on the bottom side here where Kinesis is now part of the ingest layer. So Kinesis captures those logs. It flows through that same process of getting processed through EMR, landing in the stage data. But now, if you're looking at that semi or unstructured data or analyzing directly against the logs, you may either look at Athena typically for, say, log data, or if you're doing text analysis, you may even use something like Elasticsearch, which is a fully managed version of Elasticsearch that we have there. Now I'm going to build this a little bit dense here, but I'm going to simplify that in just a second. Let's say you're looking to build predictive models. There tend to be 3 different services that people will look to. One is Amazon Machine Learning. The second is the traditional data mining tools, which is built off of a Spark cluster. and the third would be deep learning. And I'll give you just a little context of where and when people are using these. Machine learning, I kind of think of this as an 80-20 sort of service. The barrier to using it is really low. The technical skills are really low. And most people who have an idea of, I want to have a personalization model, or I want to write something that does prediction for IoT devices, machine learning can probably build those models for you. But if you want to move into something like behavioral profiling, it may not serve that, so you may then have to move up to something like running R and running MLlib against a Spark cluster, which is that second bit. Or if you move into what I'll call the unconstructed dream space, which is I need to look for patterns, but it doesn't fit a traditional model, or I'm looking at data and I don't really have the algorithms for it, you may then look to move to something like deep learning. We as Amazon, we've moved towards MXNet. There's a few different great packages out there, MXNet being the one that we support because it's open source, but TensorFlow and others also will fit into this category using machine images. Now I'm going to simplify this back down, and we'll just look at that as the advanced analytics layer. Now the advanced analytics will create models, you will have trained data, you'll have data that will have run through those models and will be published out to the data lake and then served, say, down to the data warehouse for a personalization, maybe for campaigns, or down to legacy applications if you have maybe an existing CRM system that you want to feed, hey, here's the next best offer that you want to give to your customers, it would be served through that. So looking at that platform, this blueprint, although it looks fairly simple, this is actually the blueprint that some of our best customers are using for processing those modernization and the analytics projects. So let's go to the next level. Next level being real-time architectures. So real-time architectures, again for this third outcome, we're looking at something is happening, and based on the business case, there is a time that the event starts and a time that there's a window in between where you can affect the outcome. So we call these the windows of opportunity. And it could look like somebody is shopping on your website and you have this amount of time from when they put something in the shopping basket to when they might leave, and you need to make sure that they have the right way to be converted into a sale. Or somebody has entered into a store and you want to do facial recognition on that person and then personalize a service based on that, you may have a window of time to do that. So the windows of opportunity are what define these projects. A customer of ours, Supercell. So Clash of Clans is one of their absolute blockbusters. Supercell is a very fascinating company to me in that they have 4 big blockbuster games, but they have tons and tons of games that they've launched that never went big, or games that didn't succeed. But what they've done with each one of these games, in order to build these giants like Clash of Clans, which incidentally for years was the highest daily revenue earner of mobile gaming until Pokemon, but think what you will of that. So Clash of Clans was really successful for a long time because they captured so much user behavior out of all of their gaming platforms that even when they shut a game down, they roll back the behavioral analytics into their blockbusters. They can detect things like frustration, which is an interesting measure. So you're playing a game and you get frustrated, but it's not the frustration, it's the response to the frustration to how can they make sure that you as a person are engaged in the right way to keep you in the game. So it could be you're a competitive person, so they flash a leaderboard, or maybe you are a person and you grind, and so they show you how far you are to your next level. They don't change the mechanics of the game, but how they connect with you when you're exhibiting a certain behavior is very refined and is personalized on a one-to-one basis. Now, they do this in the same way that a number of our customers do it by building a system that can detect and respond in near real time. So some common projects that we see, interactive CX is customer experience, so interactive customer experience projects. These tend to be where somebody is coming in, they're interacting with your service or brand, and you are helping to navigate them. These could be your chat bots, they could be anything that's responding to your customers in real time. Event-driven automation, like in the Amazon context, that would be you click on an order, and somewhere we have robots that go out and they collect the racks and they drive them over, and then the pickers take them off. Or the third might be something like fraud detection, where you have a small window to detect when somebody's made a payment to see, does that look suspicious or not? So how does this build in? We have that same, they'll look a little bit familiar. So you have the top layer, which is the data processing and the building of the models. But to build the models, you need to capture enough data to know what does good look like and what does suspicious look like. So now we start to build out the bottom layer, and this is the speed layer. So Kinesis, again, that on-ramp of the event, will then pipeline into another Kinesis stream. That Kinesis stream, that event capture, then gets processed. You remember we talked about EMR, we talked about that 24/7, that stream processing cluster. It will then shoot up through that stream processing cluster and land back up into your raw data area. Now, once it's there, all of that data that's been captured from, say, your clickstream data, then moves across and it gets processed in something like somebody who's running R models, or they're running PySpark, and they're looking at what is normal clickstream behavior, and what does abandonment look like, and what does boredom look like. So they'll start to build those models and publish those out. But maybe you want to do more than that. Maybe you want to do more than just analyzing what does good and bad look like, but you want to be able to capture it and respond to it. So we have a service called Amazon Lambda, not to be confused with the Lambda architecture, but Amazon Lambda, which is serverless compute. And serverless compute is your ability, without spinning up a server, to say, when something happens, when I get triggered, run some Java code or run some Node.js code. And so you can just dictate, hey, I just want to execute this whenever I see an event. Now, one of the things that you may be looking for is when you see an event is maybe you're filling in with what we call enrichment data. And so we have some AI services that were released, announced in November, one being image recognition, which I'll walk through a little bit here. We also have some speech to text. We have natural language processing. So some of the services that round out in the AI portfolio. But let's talk about recognition. So recognition is an image processing service that can do things like you serve it an image, and that image it can detect, here's the components in the image. You've got a pool and a house and what have you. It also can do facial identification of different features. Does the person have a mustache? Are they smiling? Eyes closed, eyes open? Now, where this gets interesting is, let's say that this is part of your capture of an event, and you can say, hey, I want to respond to a person based on their emotion. I can use the image recognition, I can pull some of this out, and now I can feed that back up into my response of what do I do now. So where this fits in, let's look back to the bottom layer. The event's been captured. It goes through Lambda, which is the trigger to say, I want to now do something with it. Now, we eventually want to get up to that box that says event scoring, but first we may be using some enrichment data, and that may come out of the artificial intelligence solutions. So we may do some enrichment, push that up into the event scoring engine. Now, the event scoring engine, you'll see that that's not an AWS service. That tends to be an EC2 cluster that's running. Now, the EC2 cluster operates in one of two ways. You either have more advanced models, things that have come out of, say, your R process, or things that have come out of deep learning, and they've been coded, because it's just typically coefficient-based equation. They get coded and put down into something like Python. A set of variables come in, it gets scored, and then processing happens from there. But if you're using something like machine learning, or if you're using a third-party black box provider, which a lot of our customers do, you may have a query response that happens from the event scoring layer. So it captures enough information to go out and ask a third party or ask ML, and then come back with a response. Now, the response in stats terms is always going to be between a 0 and a 1. Do I go or do I no go? Like, is it 85% likely that I should take this action or not? So the trigger of the event comes through Lambda. It goes to the event scoring engine, and then a determination is made off of the analytics models, or off those predictive models, and then it gets pushed out to a second Lambda function, which is the response. So the response handler says, okay, you said it's 85%, now what do I do? That will then trigger it and push it to the off-ramp. And remember we talked about Kinesis being the on-ramp to the event? When you're looking at a very low latency environment, what we see used for mobile gaming, for e-commerce, for fraud detection, is that DynamoDB, which is our fully managed NoSQL service, NoSQL is good for a number of things, but where it's really strong is it's very, very fast for query response, looking up a key and getting a value. So if you look at the latency from when an event happens, it's captured within Kinesis all the way up to when it's served out through DynamoDB, you're talking in hundreds of milliseconds if you have a system that has been configured correctly. So if you think about that in context of, can you scale this to fit your business requirement, there's a good chance that you can build this this same pattern to be able to solve within that period of time. So although there's a lot of stuff that's on screen here, this is really the blueprint that we see a lot of the Netflix and the Robinhoods and the Airbnbs and our really sort of flagship customers. This is how they design for scale and for speed. So the 4 outcomes, we talked through 3 of them. We talked about modernization projects. We talked about innovating for new revenues. Looked at real-time architectures, so real-time engagement. And the 4th that I haven't gone into, but it is one that will be covered in some other sessions, is how to use automation to scale. So how is it that when Airbnb operates a global infrastructure, they do it with 5 guys? Or when Robinhood builds a multi-million dollar business, they build it with 2 guys. So the automation bits, just look to those in other sessions. So where do you go with this? How do you move forward? Taking your ideas and being able to build those outcomes from the architectures. There's really four things that we've looked at. First, what is the business case that you're going to start with? And again, challenging this idea of don't start with the data. Don't start with big data. It's really hard to win that way. You don't want to win the lottery by buying the ticket. So starting with the business case and the metrics, and then narrowing down from there. Using as much as you can, decouple. Don't look at buying big services or big architectures if you can decouple. So splitting your storage and your compute where you can. As you found this pattern, as you've started to design that architecture, that Lambda architecture, and particularly where you see this is in that top layer, that data processing layer, you'll be able to templatize that and run those out as fixed costs or expectable cost sort of experiments. So experiment and iterate, and then finally use automation to deploy out and be able to operate at scale. So I want to thank you all. I hope that this is a fantastic summit. Super excited to see you here, and so thank you very much for coming out. Thanks.